What we're here to show you is the amount of energy it takes to bend a belt around the pulleys, and we're going to show you how much of the percent of the total energy your motor's using to bend the belt. So here we have a solution offered by one of our big competitors where they use this common wrap belt. I'll put it on the pulleys. These are the minimum diameter pulleys for a 5V and a polycarbon timing belt, which will become apparent why I'm using them in a second. So I'm going to tension them all. You can see on the screen here, this is the tension, and this is the amount of torque it takes to bend the belt, how much work we're doing bending the belt. And I will take this out here too. We're going to run them all about the same, not exactly the same, at 90 pounds. So we'll get this out here to 90 pounds. See it up on the screen. Try and zoom it in here right to 90 pounds. And we'll run it for 10 revolutions. So we're measuring the amount of work we're doing just to bend the belt because there's no machine hooked on here. And very soon it's going to come up on this screen right here. We're spending 5% of the total energy of the motor doing the work just in bending the belt. So you're spending $1,900 on a 50 horse drive, 4.9%, basically 5%, doing nothing but bending the belt. So now I'll reset this. You can go spend another 30 to 40% and use a cog belt from Gates or another company. We use Gates because it's typical. And we'll put it on exactly the same, 90 pounds. And you will turn it on, run it for 10 revolutions. I overshot a little, I'm sorry. We will measure this. Remember, we started at about 5%, $1,900. If you just spent the money to change the cog belts, you'll see how much you would save on a 50 horse drive. You would have saved somewhere in the neighborhood of $600, taking your energy lost from 5% down to about 3.5%. So you'd have cut it in just about 1/3. Now the next solution that's been offered is where you spend maybe 5 times as much money. Use a smaller diameter shiv to keep the noise down. This is the smallest shiv for polycarbon. It's the polycarbon belt, polychain carbon. This is the 5V, so we're going to put the polycarbon belt on. Reset this. Now remember, you're spending in the neighborhood of 5 times as many dollars on the belt and probably nearly that much more on the shivs. We're going to take this out. You need the amount of tension to carry the load so you don't have jumping of the teeth, so it's going to be still 90 pounds. I'm going to run this, and this will bring it down from that 3.5% of that cog belt of our competitors down to an amount of 50 horse down to $540, which is about 1.4% energy loss, which is very good. But up till now, that you paid 5 times for that solution to save energy, but if you would have used the new Bestorq 5VX belt, and it's called Bestorq X5, you can put that on. Again, it's in the same sheaves, the 5V sheaves. You don't have to buy the expensive polycarbon sheaves, and you don't have to buy the expensive polycarbon belt. You also have a belt that has a very low noise level compared to the polycarbon. You run that at the high speed like on fans and blowers, and it makes a lot of noise. I have to reset this tension, and again I will install this at 90 pounds. And I'll get it here and we'll start that. And in just a second we'll see how it compares. It's probably going to be very close to the polycarbon, maybe 0.1% off. 1.5 versus a polycarbon. No, it's not. 1.4, 1.5. It ends up at 1.4. That's exactly the same as a polycarbon, so you're saving the same amount of energy as the polycarbon. You're not spending 5 times as much for your shoes. You're not spending 5 times as much for your belt. You have a very good solution, and this belt will run the same amount of time. So you've saved a tremendous amount of money, got a very efficient drive, it's quiet with a regular V-belt.